So for our first construction, we're going to talk about constructing a perpendicular bisector of a line segment. So before I do the construction, we have to discuss what is a perpendicular bisector. So we've heard the term perpendicular before, and perpendicular just means that the line segments are going to be at 90-degree angles with each other. And then a bisector, bi hopefully sounds like two to you. So a bisector is going to split the line segment into two. So we're going to have two line segments that intersect each other, and one of them is going to split the other one into two pieces. So as I discussed in a previous video, you might want to go to GeoGebra, or you can follow along on these instructions that I have in your notes that talk about using a real compass and a ruler. But either way, whether you're following me on GeoGebra or you're following me with a physical compass, here we go with our construction of a perpendicular bisector. So the first thing I'm going to do is I'm going to click over here on my segment tool in GeoGebra, and I'm going to draw a line segment. Doesn't matter how long it is, it's a line segment. So the next thing I'm going to do is I'm going to go down to my compass tool, and I'm going to draw a circle. And in your instructions, it just tells you to draw part of a circle, but with GeoGebra, we have to draw a whole circle. It doesn't matter. And we're going to draw it with the center at A, and then the radius some distance between A and B. So center at A, some distance between A and B. It just happened to make it the whole distance between A and B. That's fine. All right. And then we want the same, another circle with the same radius. That's the important part. They have to have the same radius. So I'm going to draw another circle with the center at B and the same radius. All right. Why the same radius? Because we want to cut this line in two. And we also want the line, the bisector, to be perpendicular. So if we now draw a line or a line segment, doesn't matter, with points at this intersection point at the top and at the bottom, we will now have a perpendicular bisector. So if you do not believe me, I don't blame you. So what I'm going to do is I'm going to, and you can do this too, I'm going to put a point here between A and B. Supposedly this is the halfway point. So I'm going to measure it. So I'm going to go down here to my measuring tools and measure the distance between A and E. And here it tells me that it is equal to 2 units. Let me see if I can move this up here. I have to get my arrow tool to move something. And then I'm going to measure my distance between E and B, and voila, it is a distance of 2 units. So I know that I have a bisector. I'm not sure if it's perpendicular bisector. So I better measure an angle. and I'm going to measure this angle AEC. Whoops, it's giving me the wrong angle. It's giving me that whole big outside angle. So I'm going to undo that, and I'm going to measure instead the other direction, CEA. Look, and notice how it got kind of pointy there. Remember that that's our symbol for a 90-degree angle, drawing that little box in the corner. So I have one 90-degree angle. That means they're all going to be 90 degrees, but just in case you still don't believe me, I'm going to measure this other angle. Oop, it's measuring the outside. Undo. And this time I'm going to measure BEC. And look at there, I got another 90-degree angle. So I do have a perpendicular bisector here. Another thing that I can do, because these are perpendicular bisectors and because I'm using circles with the same radius, I can draw a polygon using my points here. So I'm going to start at A, go to C, go to B, go to D, and go to A. And the polygon that I've drawn, in case you don't know, is a rhombus. Again, if you don't believe me, I'm going to measure the distance. I'm going to measure the distance from A to C, which is 4, C to B, 4 again, B to D, also 4, and D to A is also 4. So all the sides are the same length. They have perpendicular bisector for the diagonals. That is the definition of a rhombus. Another cool, neato thing that you can do here is you can drag your points around and change the size now that you've got your construction drawn. And you will notice that no matter how I drag this point around, I'll drag B a little bit here too, but all of my sides are always equal. My A to E and my E to B are always going to be the same, and my angles in the center are always going to be 90 degrees.